here's the other question we looked at in class. So again, it's static rigid body. I've got a ladder standing against the wall. We've got the mass, its length is 3a. One end is against a smooth wall, the other against the floor. It's got a load of mass 2m fixed at point C. It's a uniform rod. Okay, remember that tells us basically that the mass is at the center. Then we have got it's perpendicular. Sorry, the wall is perpendicular. Okay, it's modelled as a particle. It's in limiting equilibrium. Okay, remember that. That's very important. At an angle of 60 degrees. And then we need to find the coefficient of friction between the ladder and say how we've used some assumptions. Right, okay, so we want the coefficient of friction. So I'm going to start by resolving horizontally. Okay, so if I horizontally, what have I got? I have got friction going in that direction, and I have got the reaction force where the ladder meets the wall at B. So that means that mu r is equal to P, and it's mu r because the ladder is in limiting equilibrium. Okay, that means basically that the friction is less than or equal to mu r. If the friction is bigger than mu r, our object will be moving, which it is not. Okay, so that's our horizontal. Now let's look vertically. So now vertically, I have got a reaction at A, and I've got 2mg and mg. So they're my only vertical forces. So that means that I'll take R as the positive, and that is equal to 2mg plus mg, which is just 3mg. Okay. Right. Now, I need to find out what P is to then solve what my mu is. So let's do moments. Now, I want the coefficient of friction, so I'm going to pick B as my pivot. If I picked A as the pivot, then the mu r would disappear. So I'm going to do moments about B. Okay, so from B, the first one I've got is my 2mg. So I've got 2mg, and I can multiply that by the distance from the pivot, which is going to be B 1.5, that's 2, times 2a times cosine of 60. Now remember that our force has to be perpendicular to our pivot. So if that's perpendicular, this angle here is 60 degrees. So cosine of 60. Okay, then I've got 1.5. So that's that. So I've basically got my mg times 1.5a. And again, to make it perpendicular, that's cosine of 60. And then the last one I've got, which is mu r, that's my friction. So I've got mu r, and I'm multiplied by the distance, which is 3a, the length of our entire ladder. And now this time it's sine of 60. Okay, because if I make it perpendicular, okay, that 60 degrees is marked to the horizontal. So to make it the vertical, I make it sine 60. Okay, and all of that is equal to R, our reaction going in the other direction. Okay, and that is R times 3a, distance from the pivot, times cosine of 60. Okay, so I've got that. So now all I've got to do is rearrange this so I can find out what mu is. So I'm going to replace all of the angles. Cos of 60 is a half. Cos of 60 is a half. Sine of 60 is root 3 over 2. And again, my cos 60 is a half. Okay, every single term has got an A. So I'm going to cross out A, and A. So now I should have simplified this quite a bit. So now I've got 5.5 times mg. Oh, and then I'll replace my cos 60 with a half. Okay, so that's 5.5 mg times cos 60. And then onto that, I have to add my 3 times sine 60, which is root 3 over 2. So I've got 3 root 3 over 2. And that's being multiplied by mu r. And that is equal to 3 times a half, which is 1.5, times r. Oh, sorry, 1.5 times 3r, sorry. Oops. 3r. Right, okay. So now we can simplify that further. We can replace the r's because we know what r is. So let's replace r. So we've got 5.5 mg times a half. Well, actually, let's just make that 2.75 mg. We'll add to that 3 root 3 over 2 times mu times 3 mg, which is our r, equals 1.5 times 3. Well, let's replace that with 4.5. 4.5, and our r is 3 is mg. Oh, sorry. R is, yeah. So that gives me 4.5 mg. Okay, right, fine. Now, again, you can see mg is in each one. mg, which just leaves me with 3 terms. So my mu is equal to 4.5. I'm going to subtract the 2.5 from the other side. 2.775. And then I'm going to divide it by the thing that's multiplying mu, which is 3 root 3 over 2 times 3. So that's 9 root 3 over 2. And when I put that into my calculator, I get 0.2245525, which is 0.225 to 3 significant figures. And that's my coefficient of friction. Okay, B is easy. B says state how you use the assumption the ladder is uniform in your calculations. Well, we know that uniform means that mass is at the middle, and you can see that we use that here. So it's 1.5 from this end and 1.5 from this end, and that's it.